Hello, welcome back to Educator.com and welcome back to physical chemistry. So today we're going to start talking about something called term symbols, and we're going to be spending 2 or 3 lessons on this. Before I discuss term symbols, I want to discuss a fourth quantum number. It's called the spin quantum number. So we'll introduce that and then we'll get into the topic of term symbols. So let's go ahead and just get started. Let me see, I think I'll go ahead and go, that's fine, I think I'll stick with blue today. Okay, so 3 quantum numbers so far. So 3 quantum numbers, they specify an orbital. Specify an orbital, a wave function. A wave function represents an orbital for the hydrogen atom that we saw. So we can also call it a quantum state if we want. Quantum state, or again, like I said, we can just go ahead and call it a wave function, which is exactly what it is. Okay, we have n, which is the primary quantum number, and n takes the values 1, 2, 3, and so on. And then we have L. L is the angular momentum quantum number, and it takes on the values of 0, 1, 2, all the way up to n minus 1. So L depends on n. And then we also have this one. We have the m, or I'm going to start occasionally putting a subscript of L on there. So m or m sub L, this is the magnetic quantum number, and it is dependent on L, which is why we have this subscript L. And it is going to take on the values of 0, plus or minus 1, plus or minus 2, all the way up to plus or minus L. Okay, there is a fourth quantum number. Now, I'm not going to spend a lot of time here talking about where this fourth quantum number comes from. I'm just going to introduce it, sort of tack it on to the 3 quantum numbers that we have, and if we need to go a little bit deeper into what this fourth quantum number is, we will. But I don't want to just unload a bunch of information that's unnecessary at this point. So for right now, just know that there is this fourth quantum number. Fourth quantum number. And it's designated small s, and it is called the spin. Now, in your books or in any discussion that you see online, they're going to talk about this, how an electron has this intrinsic property called spin. Now, if you want to sort of correlate it with why we chose the word spin, you can think of an electron as a ball, and a ball is spinning. Now, a ball can spin in 2 directions if you're holding it like this. It can either spin to the right or it can spin to the left. If you spin to the right, using the right-hand rule that you remember from physics, as it spins to the right, your thumb is pointing up. That's up spin. If it's spinning this way, and if your fingers go in the direction of the spin, now your thumb is pointing down, it's down spin. Now, the electron itself is not actually spinning, but you can think about it that way if it helps you. Spin is an intrinsic quality of the electron, like its mass. So it is just its quality. So spin is the fourth quantum number. It has only one value. Now, it has only one value for the electron, and that is 1/2. The actual quantum number that we're going to use, the actual quantum numbers we use and that we often see are the m sub s. Sort of like L and m sub L, we have s and we have m sub s. Now, this is the one that has the 2 values that you've probably seen before, the plus 1/2 and the minus 1/2 for upspin and downspin, respectively. Okay, so these are the spin quantum numbers. Spin quantum numbers. So, an electron with a given set of n, l, and m sub l can have m sub s equals plus 1/2, which we call upspin, or m sub s equals minus 1/2, which we call downspin. That's it. And again, I'm not going to harp on this whole idea of a spinning top or a spinning electron and things like that. It's not altogether important. It's an intrinsic quality of the electron. Okay, now when we have just n, l, and m sub l, we have an orbital. We have an orbital. We have a quantum state. We have a wave function. Now, when we add the fourth quantum number to it, when we add m sub s, when we add the fourth quantum number, m sub s, we're now going to call it something else. Instead of an orbital, we're going to call it a spin orbital. Let me rewrite we call these spin orbitals. That's it. So a spin orbital is just, it's an orbital that actually includes that fourth quantum number. Okay. So let's go ahead and change here.